Now we were left with that of the use cases what uh, that had given in fourth and fifth lab and also in sixth and seventh lab. So let's go through this and also code this. This might be a probable question, not same question will not be getting, but still the concept whatever we are coming across in these two of those questions, the same might repeat. So let's go through this. So design and implement a smart contract using Solidity program that we have done, which will be named as CryptoWallet. So the class name is CryptoWallet. Okay. The wallet is designed to facilitate a secure transaction and account management. The contract allows for ownership changes. You might allow the ownership changes, freezing of those accounts, depositing and withdraw ethers, and we will be having the transfers ethers between the accounts and checking the account balances to meet these requirements. Okay, just learning all those things like what are the functions we will be going to encounter. So write the following 7 functions including a constructor in that case, along with that of the required state variables. Modifiers and events are the new keywords here which we have to know. Okay, we'll write the code and understand each of it. So create a constructor that initiates the wallet with an array of owner address. Only these address should be recognized as owners. So at the next part we will do change ownership. Each one with one by one we'll be implementing. Let's go through the steps. As we know, the first we will be creating so the first thing what we'll be doing is pragma. As you know, we have a version on this. So point 0 is a best practice. And now we know what we have to do. The contracts. So contracts and what is the value of contracts? So opening it. Let's, the contract of crypto wallet is common. Now, firstly, what he has told, we have to implement a constructor. So, to implement a constructor, what we will be taking, let's see what he has written. Create a constructor that initializes a valid with the array of owner address, and only those address should be recognized as owners. So, array of owner address, firstly, it has to be declared at first. So, how we will be declaring it at first? So, let's go with that of address of having. It should be in the form of what? Arrays, and I will tell its name has to be owners. Now let's use this in that of constructor. How we will be using this in constructor as such? Con inside that we have address and come across it is in an array format, and they will be telling to store in temporary variable we will be using memory, and there we know we have the owners, and will be this is not the same as the O value, that is nothing but underscore we have. Then we'll open this constructor. So while using the deploy or after the compile function, we will be using deploy, right? At there itself, we have to specify the addresses where the owners are located. For example, what we'll be writing is we need to have a require function in this, telling that you need to have at least one owner to perform all the other operations. As what are the operations we just saw, right? Uh, Deposit and withdraw or transfer, all those operations to be performed on all those owners address, right? So we need to have at least one owner, so we can write the require function in this case. So it is an optional case where just we are writing it, having the owner's length, owners dot len. So owner's length, and there we will be telling it should be greater than 0. Only then you will be considering, or else we will be writing it as we need to have at least one owner, right? So at least one. Okay. So when we get on one owner, so whatever the owner we have, we will be assigning it to those values. So Owners we know, as we have declared above, that is nothing but in a public way, we know the array it has value. Whatever we get the value will be including owners. So this is conveyed, right? So firstly, what they wanted is create a constructor that initiates the valids with an array of owner address. So array of owner address was there, and only these address should be recognized as owners. So because at least only these address should be recognized as owners will be done later. But the thing what we have used in require is at least one owner is required because the number of owners should be more so that we have to perform other operations, right? So basic thing of using the constructor is done. Next part, when you talk about implement a function name, change ownership. So change ownership that allow an existing owner to transfer the ownership to a new Ethereum address. So if the change ownership is done, like from an normal the owner what he had as an address will be changing his address to a different address. So how will be implementing those? So he has to told a function has to be implemented. Say let's start with that of implementing a function. So function we come across will change owner has to be the value, and we have the values as address, and we'll be taking inside the address itself, right? Because in the change owner whatever we do, it should be reflecting from the original address to add the address which we are passing on to. For example, if my address starts with like 053 and it is being sending towards like 015, we'll be mentioning those, and now whatever we have the value is the new owner thing. New owner just public, and new owner will be telling him, and then we need the values as public, and we just don't need to do anything other else because we just have to change the owner. That's all. For this case, only this much is enough, and later we'll be checking all those values. But the thing, the change owner should only be done by whom? The value, that is nothing but the owner should be what? The For example, the change ownership or change thing should be done by the particular owner itself and no other owner. For example, if 053 is working on it, for example, I am the owner of it. I I only have the authority to change the ownership to some other people, and no other person should do. So for that, I have to use a require statement. And this ownership command, like the require statement, is used for various other functions also. So better to use it at once and calling those function every time. So how do we do that? There the concept of modifiers comes in, as they have also mentioned here, as to be use of modifiers also has to be done. So let's declare a modifier at the start so that we will be every time calling that function and using it particularly here and there. So let's use the modifier at first. So firstly, let's understand what is modifier. So, so modifiers are like pre-checks before executing a function. So they help to reuse a code instead of repeating the require statement. The require statement is like required owner should be there in that, right? The required owner should be a current owner itself. If he is not the owner, then it would be telling that you are not the owner. That is the case here. You can see the example over. Only owner is what we will be talking, and the required message sender is equals to owner. You are not the owner is the case we will be here. We'll be telling here. So the same thing we'll be following in here also. Let's implement this modifier thing. So modifier is basically what it is. It is used to it is used for reusing. So we are learning about modifier, and we'll tell only owners, only owners, and then it's like a function, and then we'll open this bracket, and there we can check whether the given person is an owner or not. So for that, we come across the value. So message not owner, it's only owner. This is not the case. We'll be telling. We'll be using a bool function of having is owner and is equals to false. And there you will be coming across for. These are all the logical things which we need to remember at first. I is equals to 0. I less than the owners dot len owner's length, and I plus, and then inside that we tell if the msg dot sender is equals to owner of I. In that case, we'll be telling is owner equals true. So this is we have to take it as true. Like this. Then we have to take break of that. So like for that, this the whole thing is nothing but the whole scenario. And the next part is nothing but if he is not the owner, we will be writing the require statement that he should be only the owner can call this function. So is owner comma will be writing what the value wants it. So if the is owner is nothing but require of his owner if he has only the owner only the owner can call this function as okay. And also the main syntax of it is nothing but we need to mention from where the execution has to start. So for that there is a unusual thing is nothing but colon. The main thing is nothing but for the execution thing, where the execution has to start, we will be using this underscore of colon. So what does this indicate is nothing but here the function execution starts. Wherever we will be writing that is usage of this can be done as public and then we can call only owners here. And after that case, after this you can continue with the following thing is what we will be mentioning. For example, change owner is called, the function is called, it automatically calls the only owner. In that only owners, it will be checking whether the given owner is the value who is sending or not. We're checking the whole, it will be traversing on the whole thing. And finally, it will tell yes if it is, then it's break and completely executes here. If it is not the case, then the required function will be executed. And totally, we will be tell underscore and colon is nothing but indicating from here the function is executed. So this was the thing which was explained in the chat GPT also. It told like what does this mainly indicate? They're telling it is nothing but from here the function execution starts. So this was the thing which was given in chat GPT. Let's see further. The modifier is nothing but it has its syntax like this. As I told in the PPT also, continue the execution of the function where this modifier is used. So where the modifier is used, from there you can execute the further code as well. Okay, now when we having the public of owns, let's create whatever the change ownership they have. We'll be pushing that ownership to that nothing but we know the owners the value, right? So owners dot push which value you have to push the new owner value. So aram se say new one. Then we come across the value of 7. And now we also come across emit of it. So this is the later part. Let's not get into that deep. So this is of having push. And next, what is the next function? The same way you have to get into all those. Write a function to deposit that allows, including the owners to deposit the ether into the wallet. So even the owners can do that, and even others can do that. So another function is deposit. So uh, deposit. We will be um, giving the inside. The input will be giving in the left hand side here itself. Whatever the value will be getting. So, but the next part, what we'll be encountering is a different case. Um, so let's see those. So public of deposit, and the main thing is nothing but it should be public of payable in that case. Why do we need a payable is nothing but we'll be able to send an ether from this function. So we need to write the main thing has to be it should be a payable function as sir has told. Payable when it is indicated we can say it as the having it should be mentioned. Okay, so function deposit public payable is done. Firstly, in the require function, what we'll be telling. So we further have that is nothing but we also come across what the values is in the deposit function. Uh, First, we have to check what are the values. So that's later thing we'll be checking. Wait, the require function, what we want, the balance of the deposit function is whatever the amount he has already. We need to increase that amount, right? The value of it. So first of all, have we done any of those called as balances of for storing of balance? Not yet. Right? So let's create an address of value first. So let's go here and create an address of values like mapping of having address to enter 256, and then we come across the values of what we can say int of 256, and we also tell it's also a public, and what is the value we'll be telling value. So this is the way, as we have seen in the previous video, how we have done for that is nothing but the mapping concept of using key value pairs. How we have come across the same thing we are doing here for the balances. Why do we need balances? It is basically useful for each and every address. We'll be storing those values in it. That is the deposit what we'll be doing it. So let's continue with that of what the deposit function. And the deposit function, each and every value should be stored, right? Balances. In that balances, we come across the value of having the message, whatever whoever the sender is. In that, in his case, we'll be doing the plus equals of which value we'll be doing the amount value, whatever the amount we'll be getting. So we'll not be sending any amount value, we'll be directly sending the value with that value. So whoever will be calling na, so he will be having his own value in this. So there is no problem of having sending some amount of it, because if we are using an amount, we have to enter the value there itself. We can do that case. We have already done that case in the previous example. So I'm just telling you in the way like whatever the value. For example, what I'm telling is usually we'll specify some ethers here, right? We'll be specifying so and so ethers. So the value, if we have to send like this, we'll be taking as such like this. If it is in the case of telling the value, give it yourself. Like in the deployed contracts, we'll be telling the message value as so and so. If we are telling like that, it's well and good, we can work on it. There we have to take a function has to be input having u int of 56 of amount, and we have to take the return function, everything. Return function is not needed, but the thing what I'm telling is if you have to take from here the value itself, we can take the message dot value as an access. Okay, message dot value is also done, and further we will be doing this is the main part. Let's make it simple. Okay. Next, we come across the next function is about withdraw function. Next, we come across transfer and get back. Let's implement each of it. Withdraw is basically what we need to know. What we need to know in withdraw function is basically how much amount we have to withdraw should be known. So we cannot mention that we can even do that. So, but let me do it in. Firstly, we have to check here as the thing, but whether the given amount is less than that of the balance. So the value what we are taking message dot sender should be the whoever the message dot sender his amount or whatever the balance what we have, right? So have to how to check the message of his balance. So wait a minute, I just have to mention this like balances of message of sender is greater than or equal to his amount. In that case only we have to enter the below case, or else we will be telling it is less. we are having a insufficient balance or something like that. Insufficient. Good. The next part, the value comes in like, okay, if it is like less than that of the balance, what we'll be doing? We'll be doing the withdrawal amount, right? I'm set to let us balance of message dot sender minus equals the amount whatever the user has entered. And also the main thing we have to know, whatever the value will be telling it. You can ask why is this line is used, that is payable of message dot sender dot transfer of amount. So message dot sender is nothing but the address of the user calling the function. So whoever calls the function, it is nothing but indicating that. Why we are making it as to be payable is because it converts that into a payable address that it can receive some ether in that case. So if you are telling payable of message dot sender, what does it indicate? You are making that address to able to receive some ethers. And we are telling transfer of amount sends the specified amount to that of the ether to that of user. Directly we can say dot of transfer. This is of payable functions thing. We are telling transfer of amount. This is of next when we talk about after the withdraw function, what was the value? We need to have the transfer function. So let's understand how the transfer function has been done. So it's a simple way of having, we need to know the which from which address to which address we have to need to transfer. So function what we'll be having, function that we have the transfer. So we call the transfer, and inside that we need to have from which address to which address. So address of to should be there and address of from should be there, right? From which address to which address we will be mentioning those values. The address of to we need to have, and transfer obviously includes that is the thing, but how much uh, amount should be there, how much amount we have to transfer from one account to other address, that is one address to other address, and we'll be doing that a public and opening. You can even ask, as we have done in deposit as a payable function inside, why not we are not doing in payable function here? So payable function is basically when we are doing it as an output, like we are giving some values by ourselves, the input value. When you are transferring an value from inside an address to another address, it is already in a form of who is able to accept ethers or send ethers. You don't need to require it to, you don't need to make it as a payable thing. For example, just implement and show you how does it work. I'll tell the required thing of having, first of all, in transfer also we need to check the sufficient balance, right? I'll just check the sufficient balance. The sufficient balance. Okay. Sender is having sufficient balance or not. And here also the same thing has to happen. So balance of message dot sender, who knows, like balances of msg dot sender, this will be deducted how much ever the amount is, and the balances of whose, the two values, right? Balances of two address whoever he has, this will be incremented. And in the same way, this is just looks. The next we come across the values of get balance. Simple, we can return the balances of message dot sender, that can be done aramse, and then we have the freeze account. So how can you do with that of get balance? It's a simple way of telling us function function of get balance, and what we have to get in that balance will be just having to return whatever the balance we have. That is nothing but if he is in the owner itself, he will be having his balance, right? So public, and in this case we can use what, it's only viewing, right? So we can use public view, and then we have the values as returns, then we come across as to be uint 256 what we are returning it. You can even specify amount as A or something, or you can even leave it as it is. It's okay. So return back this, you know, message not sender. So you're just telling jitters don't need this value also in that case. Okay, we have returned the get balance also. At the next part, when we talk about the value, after the get balance, we have the freeze accounts. In that freeze accounts, it's telling what we need to freeze if in case there is any of this crypto wallet as such any conflicts happens, we need to freeze, right? So at that case, let's write another function of freeze account, and in that what we'll be taking the address, whatever the address we'll be mentioning, we need to take that. So and this freeze account access will be given only for the owners. So we can use that address of user, and then we have public, and then we can use the only owners, right? uh, Only ones. Now when we talk about the frozen, so the main thing is how do we do the freeze account? Like we need to have an array of it so that we can store them in the form of an arrays. Like for example, how do we have done for that of balances? We can have those for each and every address we have so and so balance. We can also keep a track of what how many accounts have been which and which addresses have been frozen as such. So let's create an mapping of which are all the addresses are also under frozen thing. Public frozen accounts. So let's use that frozen accounts here as to be how do we get this. So frozen accounts of user is equals to true if he is existing. Means like whatever the value if he has, can say yes, it's nothing but frozen account. Yes, a simple way telling it is nothing but freeze whether the given address is yes, we'll be telling it's a frozen account or else it's not. The freeze account telling it like we'll just calling a function and just printing those values. So true or else it will be just indicating yes, it's all the thing is covered here. But the main thing which we are not worrying about is the event function. Why do we need an event function and everything is working fine? So it is about tracking the log. Let's see what is events. Events in the Solidity are like logs that help us to track important actions happening in the contract. They don't have effect that the contract's logic. It doesn't affect any of this contract logic. You whatever the implementation what you have done. It just wants to know the activity of it. For an external application, will be knowing whatever the blockchain events happen, whether a transfer of account, transfer of ownership happened, or a transfer of amount happened, or how much withdraw, how much deposit, everything will be dealt here. So let's understand the syntax of those events. Event will be there, and whatever the function name you have, function name will be there, or the function what does it perform. You can need not to be the same as the thing with the function name you have used, but whatever the value you need to specify is very important. Address of having indexed of users, and again you have event of amount, telling that you are using an address and then you are using that address to deposit an amount here. Let's declare some of those events. You will get to know the examples of it. Okay. So in this, at the start itself, you have to create some of those events, and after and indicating those events, you need to write it as such. Okay, let's create some of those events as we know. Firstly, we have what? The ownership transfer, right? The first function was change ownership. So let's write event. That's syntax. Event. Change owners was the thing. So change owner. And inside that, we'll be calling those values, telling it as from address. So this is nothing but how the value it is being stored, right? Address. And we have to write index of it, like at which address of it, old owner, and comma, address of old owner, comma, address, and again indexed of having what is the value, new one. And as and when we declare this, let's go with that of change owner, and we have to write, we have to show this in the log file, right? So we'll be writing at the change owners, we need to emit this, emit the ownership transferred, the ownership is transferred, or something like this function we have to call. We have to call that function and we have to tell from which owner to which owner it has been checked. So change owner will be called here, and then inside message dot sender comma new owner is the value what will be coming up as, right? Good. And the next part we'll be talking about the same way. Next function, what was the next function? Deposit function. Let's do the same thing. Event deposit, and inside that we come across in deposit what we need to know, address of it and which address we are doing it. Basically we don't need that, I guess. Okay, let's do with that which address we need to have address, and then we come across address might be a user, and then you and 256 deposit, and we need to know the amount of it. And so let's go to the deposit, and Aram say just say okay. Always remember you need to change the name of it so that it doesn't cause any of this collision, right? Emit deposit user and OS. So user and amount ಅಂತ ಹೇಳೋ ಬದಲು we'll be writing in user, we'll be writing msg dot sender, and the amount is nothing but the msg dot value, right? Next, withdraw. So withdraw is another function. Um, withdraw, in that withdraw what we will be doing the same way has to be the deposit function itself. Just will just copy this with amount, and hashtag user and amount is the same thing. Let's write another function of width of amount, and we need to emit this, emit width. There what we have to write is message sender comma the amount, we know the amount itself was there, the value. Next, function of transfer. For each and everything we are doing an event, and transfer. When you're getting to know like what was the process which was being involved, you can you can move forward this video and go to the directly correct deploy. But if you're interested in seeing this, address of having index to you and up to so transfer is also there. Let's declare all this. Transfer wait a minute. Yes. Transfer become class. Emit transfer Don't ever use the same thing. Transfer address, right? Transfer EDD. Where was transfer EDD? And then we come across message sender, comma, to, comma, wait a minute. What we were doing in the message or two, and then we will be sending from where to where it is transferred, and then okay, amount is also done. Get balance and freeze account was left. For the get balance, it doesn't need any of this. It is not involved in any of those transactions. That it is for left for the user. Let's see what the account frozen step also. So the frozen account, right? Froze, and that froze will be telling address of index of user, comma, rule of frozen. So frozen was here. Just say emit and froze. Next, it was like message dot sender, or we come across here we have mentioned it has to be user itself, right? User, comma, true. Okay, so all those events is declared. Let's check once, whether we have got any other require function in this case. Let's see one by one. Oh, okay, cool. We have done all the event function we have done, and only owners of having all require, and constructor we have done this. Then, we come across the requires of owners length is also greater than 0. Owners dot push is also good, and emit function is done. Okay, so one more thing is nothing but while doing a withdraw function, if it is already, or while doing a deposit function, if the account is already frozen, how can you do the deposit? So let's write the require of having not of frozen. So frozen accounts, and that if that value it's already there, then the account is already frozen. Simple. So frozen of accounts, it's message agenda, your account is already frozen. This might also be used for the thing of what in withdrawals, right? Cannot even withdraw from what is already there. So withdrawal, so it is used. Then the transfer also you can't do when it is already frozen. So better practice that you can write it the function now. Yeah, require function is done. Then anywhere if it is like needed, yes, it's well and good. Now let's start with that of execution. Compile. What is the value? Bool of his owner is equals to false. What happened here? Let's compile once. Okay. Now let's deploy this. So for deploying, as I told, as we are using a constructor, so we have to give the address at the start itself. So let's open a notepad for storing those address at first. So notepad is open. And okay. In the notepad, we can take up those values of copy account as to be the first address we are copying it. and we are storing here. So always it has to be stored in an array form. Yeah, then take this. What is happening? Let's go with another address. Copy it. Open Notepad. Let's clear this. Again, the best. Let's copy another address of third. Copying it. Store this in here. Comma. Open. Okay, three addresses are enough. Control C, and let's store here. Control V. Deploy. Done. Next, what we come across the values is deployed contracts is already done, and we have all the functions here. Let's do it together. Firstly, let's deposit some of those amounts in this. Okay, let's do this in the form of way or something like that. Can do it in way, but the balance is showing in ether, so let's do it in ether. Ether. So it's nothing but let's deposit 10 ethers at now. Deposited finally 10 ethers. So remember the value is being storing in the form of way. This is very important whatever you have used. So you need to be knowing in which form it has been storing, because for the next purpose like doing some withdraw function, you need to specify in this variable itself. You cannot directly tell 1 ether I'm doing it in 1 ether. You cannot tell it like that. So better to copy this how much whatever the 10 ethers means in that case. So let's copy this in the way of having balance equals 10 ether. Okay, cool. And the next part, let's do it out of having deposit is done now. We have 10 ethers in us. So let's get the balance for the 10 ethers. And in which this one is it happening? It is happening. Okay, let's see whatever. The next part we can withdraw some of it. Let's try to withdraw. We know. So let's try to withdraw from 5 ethers. We have to specify like this so that can even convert this function into an ether form, but let's do this. Withdraw 5 ethers from 10, it has been changed to. Can go back and see it was 10 and now it's 5. Let's see the balance now. Yeah, it's been reduced. Let's work on some of those of with addresses now. So we do the change of owners and freeze accounts and so and so. Let's do that of change of owners. So how we can do with owners is nothing but this is the owner itself. I'll change the owner from other from this to, let's say, let's copy this and come back to, I've copied it, right? I'll just say change the owner to so and so. Let's see whether we have copied the value correctly or not. Yeah, we have copied. Okay, we have copied it correctly, and next we'll just say change owner. Yeah, it has been done. If it is not done by the owner, what happens? Let's see. It's called as, right. Let's, no, okay, this was also included. Wait a minute, some other thing. This was the, so only the owner can call this function now, not the owner. Now let's get back to the thing. Next we need to deposit everything. Deposit is done and withdraw is done. Freeze account, let's see, we can freeze the account. Any of those accounts we can freeze. So let's copy the first this thing and let's freeze its account is freeze. Now, well, let's try to deposit some of those function for it. So let's add some 1 ether to it, and which we have freeze. Let's open that. It will 0.5x, right? This we have already freezed it. Let's try to deposit in it. It tells the account is already frozen, working. And let's withdraw some 5 ethers in this. It also scolds us. The already is frozen. and withdraw. And let's try with that of balances, which we have already not frozen those. Let's try with balances now. So okay, when we are transferring something from one address to another address, let's try from one address to another address how much we can transfer. Okay, let's try to transfer from a V thing to this thing, and let's copy it, and let's place the amount, how much ever the amount we know, right? Let's transfer around 4 ethers to this. First of all, do we have the balance? First of all, I guess we don't have the balance, or let's see what happens. Yeah, insufficient balance is there. So we need to deposit in this. So 04B we have to go. No, this is the value. Okay. Let's see the get balance on this case. We have 0. Firstly, we have to deposit in this. Let's deposit around some 10 ethers in this. Deposit. Deposit is done. Let's get the balance. 9. Wait a minute. What did I do? Okay, okay. It was a different. So now let's transfer this account from, we will be transferring 5. Now we will be doing now. Transfer. Now let's get the balance. We're putting 4. Simple. Okay, let's check whether the account is frozen or not. Balance we have checked, right? What are the balances? Okay, directly we can place this and we can get the balance of each of it. Let's see if we can get the balance or not. Balance of 0. Okay, let's get the balance of the current address itself. We have transferred this, right? You can see here it's 3. Yeah, okay, because you have transferred one. Now let's see that are the frozen accounts. So what is this frozen account? So whether the given address is frozen or not, we are just checking it. As we know, we have made the account. This account has to be frozen. Let's check with that frozen. True, it's frozen. Next, owners. Whatever the value we had, 0th owner. Who is the 0th owner? Yeah, the first value was 0. This itself, right? Cool. So this is the basic implementation of the whole thing. So to give a quick recap about it, as we have used the event function, we have learned about the modifier function, and we have implemented each and every function. We have understand about the constructor and how to deal with out of every other addresses here. This is of one of the functions of what we will be working on as the crypto wallet thing. So it's all about the crypto wallet. Thank you.